Okay, hi everyone. Welcome again to our fourth Discovery Farms webinar in the series Unmasking Misconceptions. I hope you all are doing well, and we really appreciate you taking the time to join us today. I'm really looking forward to today's webinar. It is the second part of Wetlands webinar, and today we'll focus on wetlands for on-farm water management. So we're going to dive a little deeper into some wetlands information with Erin O'Brien and Tracy Hames from the Wisconsin Wetlands Association. Hopefully everyone can hear me all right. A reminder, if you are a crop consultant hoping to earn CEUs from today's webinar, please fill out your name in the chat box and we'll get that taken down and you'll receive your credits. A little Discovery Farms introduction. So my name's Erica Olson. I work for the Discovery Farms program, which is part of the University of Wisconsin Division of Extension. And hopefully all of you are subscribed to our email list. If you're not, I would encourage you to visit our website and scroll down to subscribe for updates here and fill out your information, which will be your ticket to receive information about upcoming Discovery Farms events and research information. We are an on-farm water quality research and outreach program. So we work with farmers across the state of Wisconsin performing water quality research, and then we turn that information into results and data to be shared with people like you. We publish a quarterly newsletter, which hopefully you can see now, called The Tree. And this is a great way to receive information from Discovery Farms. So if you haven't subscribed to our email list, I encourage you to do so and you'll receive this newsletter. And with that, I'm gonna stop sharing my screen. There's a poll going on. If you would kindly fill that out, and I will let Erin and Tracy from the Wisconsin Wetlands Association begin sharing their screen, and we'll get started.
Thank you, Erica. Can everybody hear me?
Yep.
And can you all see the screen?
Yes.
Okay.
Yes.
Well, good afternoon, everyone, and thank you for joining us today. And also thank you to UW Discovery Farms for inviting Wisconsin Wetlands Association to collaborate on this program. My name's Erin O'Brien, and I'll introduce myself and my co-presenter in a moment, but I'd like to start by telling you just a little bit about our organization. So Wisconsin Wetlands Association is a non-governmental, nonprofit organization, and we're dedicated to helping landowners and communities understand how wetlands can be used as solutions to the water-related issues they face. And of course, that is the topic of our webinar today. We do have a website. It's wisconsinwetlands.org, where you can learn more about us. And at the end of the presentation, we'll have a slide posted with our contact information if you'd like to get in touch with either of us. So as I mentioned, I'm Erin O'Brien, and my co-presenter here is Tracy Hames. Tracy, say hello.
Good afternoon.
Sorry, I had to have you unmute on the quick. So you can read a little bit about our backgrounds here, but in a nutshell, both of us have been working in the realm of wetland conservation for a very long time, me in the realm of policy and educational program development for local government and other public audiences, public and private audiences, and Tracy more in the hands-on, on the ground, working on the landscape with farmers and communities. So very quickly, I'll talk through our goals for this webinar. And of course, this was a two-part series, and I know not all of you were on part one, so we'll try to do some quick review of some of the things we covered along the way. today, but we have three goals. The first are learning goals to increase participants' understanding of basic wetland and hydrologic processes, how on-farm management is tied to watershed concepts, and how wetlands can help address on-farm and watershed scale issues. In keeping with the theme of this webinar series, we also aim to address some common wetland misconceptions and build interest in using wetlands as solutions to water management issues. And then we really want to treat this time together today as a sampler. We're looking to whet your appetite or your interest, so to speak, on wetland conservation practices and how they fit in agricultural landscapes. And maybe most importantly, we're looking to get input from you on wetland data, training, or technical support needs, some of the things that would be useful to you to start thinking about how to incorporate some of the concepts we'll be presenting today. And so we'll have a few poll questions going throughout the seminar today, and then there's also a few additional follow-up questions where we'd like some input from you in the post-webinar evaluation form that Erica will send out. So what are wetlands? In a nutshell, they're the places on the landscape that exist between where it's always wet and it's always dry. They're transitional zones, places where water has historically pooled and formed unique features. So because of this, we have many varieties of wetlands existing on the spectrum of wetness to dryness, and lots of different types of wetlands. Some wetlands are always wet, some are always closer to always dry, and many in between. And this diversity makes a big difference in terms of where wetlands are on the landscape and how they function. So to address the first misconception, we're not talking about scrapes today. Most people, when they hear about wetlands and wetland restoration, their minds go immediately to wetland wildlife scrapes. A scrape is a technique where a shallow basin is literally scraped off the soil to hold either groundwater, surface water, or both. And they're conducted to provide wildlife habitat benefits and aren't necessarily designed to provide the hydrologic benefits that we'll be talking about today. So we're asking folks, anyone that when they hear the word wetlands, pictures something like this or something vegetated like shown in this photo, and thinking about, you know, ducks and recreational uses, to try to put that out of your mind, because we are today talking about a broader array of types of wetlands and a broader array of wetland functions. We're also really trying to address the misconception that wetlands and agriculture are incompatible. So the focus of our presentation today is about working wetlands. And that means wetlands that fit well on a working farm or in an agricultural landscape, and that can be restored to the landscape or maintained on the landscape while also supporting a healthy and vibrant agricultural economy. So because we're covering, so this is our topic: how can wetlands be used to address water issues? But we're covering, this is a very large subject, so we're not going to be able to go in depth on any particular practice, and candidly, a webinar is not the right forum to train in depth on the use of practices. That's work that needs to be done in the field. So today what we're going to try to do is instead talk you through a process via a series of questions that you can ask yourselves and those you're working with to help determine if, how, where wetlands can be solutions to the issues you face on the farms you help manage and in the watersheds where you reside. And again, we'll be asking for more in-depth feedback on where training or other technical support might be useful moving forward on the items that we cover today that you're interested in. So with that, Erica, we have a couple of poll questions we wanted to launch right here. The first being, please rate your current level of knowledge about on-farm wetlands management practices. And this is just to help us gauge both, you know, who's on the call and what you might know currently. And it'll also help us see how effective the material we presented today is. And then the second question, which of the following best describes your experience with restoring wetlands to address on-farm water challenges? So have you been involved in wetland restoration activities in the operations you work with yet? So let's take a minute or so. Are folks seeing the poll? I don't see, there's some voting starting. There we go. Take another few seconds here. Looks like we've got almost everybody responding. Okay. Thank you, Erica. And with this, I think it's time to turn the slides over to Tracy.
Great, thanks, Erin. I hope everybody can hear me. I will be asking Erin to turn the slides because she's driving the PowerPoint presentation. Thanks to social distancing, we are not in the same room today. We are both, I think, working from our homes. So great, well, let's dive in. In part one, we talked about the importance of wetland position. Where you are in the watershed helps determine what you can do to affect water movement. And as Erin said, we're going through a series of questions in this presentation to help you think about how to address the water management issues you have and how wetlands can be a part of that. So we'll be starting out with where are we in the watershed? How do you find out where the lands that you manage are located? Next slide. So resources like Wisconsin DNR's Surface Water Data Viewer is a great place to start for this information. This web-based mapping tool has a lot of information for on-farm and watershed planning. Generally speaking, upper watershed areas are above or along tributaries and farther away from the main stem or outlet of the river or creek, whatever's flowing through your watershed. Middle watershed areas are generally along the main stem of the river or creek where the water is transported. These are the floodplain areas. So when we say middle watershed, we usually mean the floodplain areas flowing through the area. Anything even halfway down a watershed that is up the hill is still considered upper watershed. Lower watershed areas make up the places closest to the watershed outlet. That's where the water enters a larger body and leaves the watershed itself. So in this photo, the purple line is the watershed boundary of the Little Plover River watershed. We'll be referring to the Little Plover River watershed throughout this webinar to help provide some real-world examples of the concepts and the practices that we're talking about today. Oh, and by the way, the yellow box in the middle shows the upper portion of the river where a lot of our examples are going to be located. Okay, next slide. So question 2, where does my water come from? Water movement through a watershed is influenced by many factors: geomorphology, soil type, slope, vegetation, human-built infrastructure, weather patterns, groundwater dynamics, and many other things. So knowing the sources of the water moving through the lands you manage is a fundamental piece of knowledge that you'll need. So let's quickly review some of the common examples of where water comes from. Okay, next slide. Rain and snowmelt. There's a lot of rain and snowmelt in this photo here. And some watersheds are fed mainly by surface flow. Next slide. Groundwater. Some watersheds are fed mainly by groundwater, and some have combinations of surface water and groundwater. Most have combinations of surface and groundwater. But where the water comes from, whether it's surface flow or groundwater, has very important implications and differences. We don't have the time and ability to go through all those differences in this webinar. I wanted you to be aware and thinking about that, of where the water is actually coming from that you're dealing with. Next slide. Of course, irrigation is a human-influenced water source that is very important in many portions of Wisconsin, especially in the central portions, and especially important in the Little Plover River watershed, where we'll be providing many examples. Okay, next. In the Little Plover River watershed, as we said, irrigation water is the major source of agriculture. And irrigation in this area is provided by groundwater pumping. That seems like a no-brainer in Wisconsin, but if you go out west, you'll see a lot of irrigation is fed by surface water diversion, actually diverting water from rivers and creeks out into canals to feed the farms. Groundwater pumping in the central sands area especially relies on infiltration of surface water annually back into the ground. So the groundwater surface water connections are very important in places like this. Also in the Little Plover River watershed, 80% of the river's annual flow also comes from groundwater. So when you're thinking about flow in the river, it's all about groundwater in a place like that. So as we'll see in a few minutes, surface flow, snowmelt, and runoff events also important sources of water that influence watershed issues. Next slide. So third question is, how has the way my water moves changed over time and long-term, short-term watershed and on-farm? So another piece of information fundamentally important to understanding your water resources, your issues, and how to solve them is how water historically moved across the landscape and how it moves today. We talked a bit about this in part one, so today we're also just going to show a quick review of some of the changes that have occurred over time. Okay, next. Upper watershed drainage ditches, important for making lands dry enough to farm, also act as conduits for floodwaters. These ditches concentrate flows, sending them downstream quicker and in larger quantities. They increase the energy downstream and contribute oftentimes to infrastructure damage. So they may be draining lands upstream, but they're affecting lands downstream. They're very efficient at lowering groundwater levels, but they are also important conduits of flashy runoff water. Next slide. So drainage ditches and tile systems have made our historically very wet state into the incredibly productive modern agricultural landscape that we benefit from today. As we saw in part one, ditches and tiles have created some important water flow and water quality challenges. We'll address some of the issues related to this in this webinar. Next. One of the most common ways we've altered our water movement is through ditching and channelization. In this photo from 1992, channel through this wetland is not large enough to drain it, but it is large enough to remove much of the wetland's water holding capacity. In this photo, the water flows from right to left. And remember this photo, we'll see this place again later on in this webinar. Next slide. So narrowing of floodplains is a common occurrence as well. We've developed a lot of the areas where the water used to spread out. And the narrowing that we've expressed on our floodplains forces flood flows to move through obviously narrower pathways. Forcing the same quantity of water through a narrow pathway increases the flashiness and the energy of the water movement, results in what we often call the fire hose effect. So narrowing down a floodplain, squeezing the same amount of water that used to spread out into this area is increasing the energy and especially the erosive capability, helping cause infrastructure. Next slide. This map here shows the extent of high capacity well development in the Little Plover River watershed and the surrounding area. In irrigated landscapes, groundwater removal has changed the way our groundwater and surface waters interact. So even though the water change has occurred underground, it makes big differences throughout the watershed here. And you can see a lot of development in certain areas in Wisconsin. Next. So here's an example of how water movement has changed in the upper portion of the Little Plover River watershed. You have two photos here, one from 1937 on the left and one from 2016 of the same piece of land, a headwater wetland complex in the Little Plover River. And here the drainage ditch was put in somewhere around 100 years ago. That's the orange feature on the photos. You can see on the left that in 1937, much of the original 300-acre headwater wetland complex at the bottom of the photo was still intact. See how wet it is on the left-hand side? Years of drainage and groundwater removal, however, changed the hydrology over time. Today, looking at the photo on the right, the headwater wetland complex is much drier. Trees have taken over what was once a grass sedge wetland area, and the channel itself is now disconnected from the floodplain. The results are flashier floods occurring. The river channel is misshapen. We'll talk a little bit about that later on. And during drought years, the channel has been known to dry up. Knowledge of these changes has helped us and our partners understand how to address the challenges that we find in the Little Plover River. So stay tuned for more about this area. Next slide. The fourth question we look at is what issues have resulted from the changes, whether on farm or at watershed scales. So what issues are we dealing with because of how water movement has changed over time? These changes have, unfortunately, cascading effects throughout our watersheds. So what we do upstream influences downstream, and that influences further downstream, on, oftentimes cascading and making our issues in the lower portions of the watershed very challenging. So that's why a lot of times when we're looking at the issues that we're dealing with, even on farm, we have to take a watershed perspective, because what's happened upstream many times is affecting what's happening on our lands that we're managing. So let's review a small sample of some of the modern challenges we face today. Next slide. One is floodplain disconnection. Honestly, we've largely lost most of our healthy floodplains in Wisconsin through one reason or another. And the loss of upper watershed wetlands above these areas has helped deliver, as we said before, sediment and flashier flows from the upper watershed areas into our low-lying areas. And in this photo, you'll see there's a line of deposition. That's soil that actually eroded from upper watershed areas and was deposited in this former floodplain region. Sediment deposition often leads to disconnection of a river and its floodplain. And when the river and the floodplain gets disconnected, oftentimes what happens is the river with extra energy expresses that energy by digging itself deeper. So the other white line you see on this photo is the incision. The deposition came in, disconnected the floodplain, the river energy increased, and it started cutting itself deeper, further disconnecting it from its floodplain. So when a river can't interact with its floodplain, the flows are concentrated, they build up energy, and they cause the river to incise, as we just showed. Incision then exacerbates disconnection and increases the flashiness of flood events downstream and infrastructure damage. By the way, this photo is the West Fork of the Kickapoo River. It takes a really big flood event for the water here to go out of bank and connect with its floodplain. Next. Upper watershed alteration and loss of floodplains also puts water in places where it did not exist previously. And if you've got a structure like this in one of those places, you're not a happy person. Next. Of course, loss of upland storage can also increase erosion in swales. And a lot of you folks deal with farm erosion. We'll talk some about that later. Next. Flashy runoff can also result in large gully formation. Gullies like this can be very difficult and expensive to repair. That's a big one there. Next. So upper watershed changes also often move water downstream that was previously stored upstream. So in other words, when we're draining our upstream areas, that water has to go somewhere else. And where does it go? It goes downstream. So oftentimes when we make our upper watershed drier, we're actually making our lower watershed areas wetter. And so in these instances, higher groundwater tables can result, making lower watershed areas very difficult to farm. Next. And ironically, the opposite effect can also occur in some watersheds, depending on the soil and the geomorphology that you're dealing with. Loss of upper watershed storage in these cases sends water downstream and out of the watershed altogether, usually at a faster than natural rate. So in these situations, both the lower and the upper areas can go dry. And this is a photo from a creek in Central Sands area, not the Little Plover River, which also has famously dried up on drought years. This is actually Duck Creek, southwest of Little Plover River. Next. Oh, wait, we have a poll to launch.
Yes, Erica, poll number 3, please. The question here will be, which of the following issues are you most concerned about on your farm or on the farms that you work with? And you can choose the top 3, please. We'll give this just about 15 seconds more or so. Thank you all for your answers.
Whenever you're ready, next slide, Erin.
Okay, let me just, okay.
Okay, next question. Where are current and former wetlands located on my farm or in my watershed? Locating current and former wetlands on farm or in the watershed is the first step you need to take in determining the locations where wetland practices may be best applied to help solve your water issues. It's very important to remember that if you're doing wetland restoration, doing the work in places that were formerly wetlands is paramount. If you're trying to put wetlands in places where wetlands never existed, you'll have a very difficult path ahead of yourself. Next slide. And once again, the Wisconsin DNR's Surface Water Data Viewer has a lot of information that can help you identify current wetlands and other features that will help you identify where wetlands are or where they used to be on the landscape. The orange polygons in this photo show what's left of that 300-acre headwaters wetland complex that we talked about earlier in the Little Plover River watershed. The red circle is the historic extent of the wetlands that existed there historically. Next slide. And this map shows the same area highlighting hydric soils, also known as wetland soils in the same headwaters wetland complex. The hydric soils really help show where wetlands have been lost and where they may potentially be restored. Now there's other information that we just don't have time to go into, things like potentially restorable areas and things like that, wetlands that are on this online tool as well, that as you're exploring the Surface Water Data Viewer, you'll learn about those features as well. Next slide. So next question is, how do I determine the right locations for incorporating wetlands as solutions? So we found out where our wetlands are. Which areas of the wetlands where they are now or where they used to be, how do I know where I should do practices to help solve my water issues? So let's think about how we prioritize our efforts to put the right amounts of the right wetlands in the right locations. In the last webinar, we talked about random acts of conservation. Too often that's been the way things have occurred throughout our nation. We need to prioritize the work we're doing so we can be most effective addressing our water needs. Next slide, please. And as we always say, look upstream. In most cases, if you have a water problem, the solutions are going to be upstream. Now, we talked about this in part 1 as well, but it bears repeating. Results of upper watershed wetland restoration actions can help reduce runoff energy, reduce the flashiness of floods downstream, recharge groundwater, and help reduce high groundwater levels downstream. So always be looking up, up, up. Next slide, please. But what about nutrient movement? Also, as we said in part one, Discovery Farms is doing a lot of work studying nutrient movement. So seek out their information. They've got a lot of information on different things. And from a wetland perspective, studies are coming out now that are finding that wetlands are most effective managing nutrients when they're strategically located to intercept as much runoff water as possible. So the placement of wetlands in terms of nutrient movement and handling those issues is paramount. The study shown here, published in 2018, shows that nitrates are reduced most effectively in this study when wetlands are located in the pathways of water movement. So they're intercepting the water that's flowing across the land that has nutrients in them. Next slide, please. And here's the study's worst case scenario. The wetlands in the catchment shown here are mostly disconnected from the water running off the land. You can see the wetlands on either side in a ditched area running through the middle, but none of the wetlands seem to be physically connected to the channel itself. So nitrate levels in these waters leaving the catchment are higher than in the waters leaving the watersheds with more wetland connectivity. And the orange circle on the graph on the right shows the levels of nitrates in the waters leaving this catchment. Next slide. In contrast, this study's best case watershed scenario shows a catchment where wetlands do intercept most of the runoff. The scenario here shows the lowest nitrate levels in waters leaving the watershed. In this example, most of the wetlands occur at the bottom of the catchment. Now, if the wetlands were more spread out upstream, oftentimes the same results may be realized with much less wetland acreage. In other words, put your wetlands as high up as possible to capture the nutrients as soon as they're leaving the farm and entering the runoff area. Now, incidentally, on the graph there, you see the orange circle shows the nitrate concentrations in the waters leaving this watershed, much lower than the first example. So where your wetlands are located, very important. Next slide. And there are several new functional assessment tools being developed to help you identify locations where wetlands could be applied to address very specific water management needs. The online tool we're showing right here is called Wetlands by Design. It was created through a partnership with Wisconsin DNR and the Nature Conservancy. This tool, you can play around with different functions that you want to assess. And once again, this map is in the upper watershed area of the Little Plow River, same area that we've been highlighting on other slides. And you can click on features like, well, what wetlands may help manage runoff? What wetlands may help with phosphorus? What wetlands may help with other nutrients? Just remember, online tools like these are very coarse and should only be used for general planning purposes. These tools help you put the big circles on the map, help you hone in at least on a watershed scale of where wetlands could be effective. There is still no substitute for boots on the ground knowledge. So get out of your office, get out of your truck, put your boots on and get out in the mud. Understanding in person the water movement over time on the waters, on the lands you manage and the watersheds you reside is the most important way of learning these things. Okay, next slide. So let's get into practices. What practices can I use to incorporate wetlands as solutions to the issues that we've looked at today? This is the fun part. This is the part where we literally could have a week-long or a whole semester class talking about the practices you can employ to solve some of these issues with wetlands. So let's look at what's going on the ground. We'll give briefly a few examples and give you a sense of what some of this stuff looks like. Before we do that, however, I want to emphasize that there are no recipe books for this kind of work. You have to do your homework. You have to go through the questions we talked about earlier in this presentation and know what practices are appropriate in what situations. When I'm talking about this, I always like to quote Miles Davis, the famous jazz trumpeter. He's famously said a quote that goes, there are no bad notes in jazz. There are just good notes placed in the wrong situations. And that's true with restoration practices as well. Oftentimes we'll find something that works really well in one location, so we want to apply that everywhere else. If you're applying good practices in the wrong locations, you can have less than desirable results, sometimes disastrous results. So you have to do the work, you have to understand what's going on. There's no substitute for understanding the hydrology, how it flowed historically, what's changed, and what have those changes brought that are causing issues today, and how can we fix them in a modern context. I will also say that many of the practices we'll be talking about from here on out have been applied much more commonly outside of Wisconsin than they have been applied inside of Wisconsin. So as we said earlier, we hope this webinar whets your appetite for exploring wetland practices on farm and across watersheds. Okay, Erin, let's dive in. And we'll start with the upper watershed wetland restoration practices that used to address the issues in the upper watersheds. Next slide. So the photo here is looking upstream at a spillway placed at the very top of a drainage complex in Rusk County. This spillway reestablishes wetland hydrology above the spillway. So instead of having this portion of the drain just draining the waters around this area, because it's at the very top of the watershed, the very top of this drainage unit, they decided we didn't need drainage in that location. Let's put a spillway, let's put the wetlands back to help store water. So wetland restoration actions such as this are very effective at helping address downstream water issues, especially issues related to flashy runoff, excessive groundwater levels. Look for locations always to capture drain water on the properties you help manage and in the watersheds you reside. Look for them as high up in the watershed as you can. Find creative places like this to store water. Next slide. This is a close-up of the spillway structure on the same area. On the right is the top of the drain, so water is flowing from left to right in this photo here. When it gets high enough, it goes over this spillway and enters the drain and flows downstream. Much of the water you'll see, this photo was taken in the summer. Oftentimes in these situations, you won't have surface flow entering the drain, but you will have groundwater flow entering the drain. And the groundwater flow is often colder and cleaner than the surface flow that would be going over the top of the spillway. Next slide. So in some situations, especially on farm, it's useful to have the ability to manipulate the water levels in your storage wetland. A structure like this one, which we call a half-round riser, it's a board structure. You put boards in to raise the water level in the wetland, and you take boards out to lower the water level, and the water flows through a culvert down the drain and on down the watershed. So these structures help retain water in the spring, but by lowering the water later in the summer, you can actually use these structures to dry up your wetlands. And sometimes it's important to dry up your wetlands for a couple of reasons. One is maybe you need to go in and do weed control, or maybe you need to go in and hay or graze the area, and you can't do that when there's too much water in there. So water control structures in management like this are very important. They've been oftentimes dismissed by some wetland folks because they say, well, there's a lot of maintenance involved in a structure like this. I will say on farm, these structures fit in very well because you're doing annual maintenance with the other infrastructure on your farm. And a structure like this literally will last at least 40 years before it needs replacement. And the maintenance in between that is actually very minimal over time. So to me, that seems like the benefits of a structure like this oftentimes far outweigh the maintenance required over time. Next slide. Another important issue is in what we call erosion-induced wetland loss. It's a big problem in headwater areas. The head cutting shown in this photo works its way farther upstream and into the wetland. The wetland continues upstream from this head cut area. And every time there's a storm event, the head cut moves farther and farther upstream. At this location, actually, every decent rain event, the head cut would move about 5 feet. So you translate that over time, and you've got a lot of movement, a lot of erosion going on in this situation. When you have this type of erosion entering your wetland, it loses its capability to hold upper water, snow melt, and precipitation. So resting head cutting like this will help retain the water holding capacity of these wetlands. One way that's commonly done to arrest this development is using rock grade control structures. And we'll talk about rock grade control structures in a few minutes. Next. So swales and cover crops are also commonly used and generally very effective at slowing runoff. In some situations, however, adding wetlands can increase the effectiveness of swale systems. I would say in most situations, however, wetlands can improve the ability of swales to manage water. In this photo, you'll notice that the swale is beginning to erode. See in the bottom right portion of that, you can see the erosion occurring. And they've even put in some hay bales and things to try and slow that water down to do what a wetland could do if it was well placed, holding that water, slowing it down. So wetlands in these situations will probably work a lot better than emergency placement of hay bales. So left unchecked, the head cut here will begin to form and start moving upstream, losing the ability of the swale to manage the runoff. Okay, next slide. And here's what it looks like. Oftentimes, when you're looking on farm, when you're looking in your cropped areas, you can find flat areas associated with the swales or in other places where water holding capacities are very likely to be successful. So think about that and find these places and allow the swale water, the water that's moving through the swales, to slow down, to spread out, and to infiltrate back into the ground. Next slide. Here's an example of a groundwater recharge wetland. Groundwater recharge wetlands capture runoff that otherwise would flow directly into rivers, creeks, or lakes and be lost downstream, also increasing the flashiness of the river flows and things like that. So instead of the water being lost to the river, in a groundwater recharge wetland, the water is held and allowed to infiltrate back into the ground. Recharge wetlands are especially effective in sandy areas such as our Central Sands region. Recharge wetlands may only be wet during snowmelt and spring rain events, but their effect on the water flow persists long after the spring rains have eroded. Remember earlier we said irrigated agriculture with high cap wells is dependent upon surface flow infiltrating into the groundwater. This is one of those structures that helps water move down and go back into the ground. This photo actually is in the Little Plover River watershed, and the modeling that's been conducted in that area is showing especially the importance of features like this, of getting runoff and retaining it and putting it down into the ground. Next slide. And here's that same wetland in July. So you can see it's dry and the vegetation is growing, and it served its purpose capturing the runoff that would have been lost and soaking it all into the ground. Next slide. Of course, wetland buffers are very important as well. When they're placed at the bottom of cropped fields, they help keep runoff from directly entering ditches and streams. A lot of research is going on these buffer type wetlands now, especially at the bottom of tiled fields. Minnesota is doing a lot of work in the Minnesota River Basin on these situations, and they're gaining a lot of popularity now. So if you've got tiled areas that are dumping water right into a ditch or right into a river or creek or waterway, think about, do you have areas that at the bottom of the field maybe are difficult to farm, where a treatment wetland like this would be a useful feature. Okay, next slide. Okay, back to the Little Plover River. Now remember that large headwater wetland complex that we talked about earlier? We learned that it had been mostly drained by this orange drainage ditch running through the area there. what happened was the ditch was moving water, bypassing this wetland, and the blue arrow you see is a natural channel that would flow into this whole wetland, and the drainage ditch was moving water away from that historic natural channel and taking it around the bend, and it never entered the wetland or the natural channel. Dumped it downstream right into the river and provided flashy flood flows during runoff events. So let's talk a little bit about how we fixed this situation. We found that the drainage ditch shown here in orange was intercepting runoff and groundwater, and the flow entered this spring-fed headwater wetland was not being realized. In fact, if you look at the spot on the ditch where it turns west, right near the tip of the blue arrow, where the orange ditch turns right there, we used to be able to stand right there looking at the orange ditch and looking at the natural channel, and you could see an 8-foot difference in elevation of these two features that were right next to each other. And of course, the natural channel was dry or almost nearly dry for a good portion of the year. Okay, next photo. This drainage ditch was causing runoff to bypass the wetland complex, as we said, delivering flashy runoff directly into the river downstream of this large area. There was no flood flow buffering because the flows never entered the wetland. This photo here shows the ditch during a snowmelt event a year ago in March 2019. Notice the orange circle. It's a test wellhead structure. You'll see it again in a couple of slides, so for reference, but this ditch is moving a lot of water right now, and that's water that was not entering that wetland. When I took this photo last year, the wetland area was actually did not have any water in it during this runoff event. It was very, very disturbing. Next slide. So our solution involved filling in this ditch and placing a spillway at the top of the fill area that directs any runoff into the formerly bypassed natural channel and large headwater wetland complex. You see the blue arrow now takes the water that was coming down the drain and puts it into the natural channel, entering the large headwater complex. Now, from a farmer standpoint, this project made not only hydrologic sense, but also economic sense to them. And the reason is the farm area this place was helping drain was experiencing very, very wet situations anyways, and they had a very difficult time getting a crop off annually. So it made sense to them to fill in this ditch and take this area out of production. And this ditch fill also helped the neighboring farmer who benefited from the rise in groundwater level due to this work to help make his pasture land more productive. So I want to say too that in this area, the area that is not orange anymore, that's where the ditch fill occurred. Now, there's a difference between totally filling a ditch and putting ditch plugs in. And I will give a plug, no pun intended, to ditch fill, because ditch fill is much more effective than plugging ditches. And many times we'll plug a ditch, but the ditch is still there and it still draws groundwater out. It's just not flowing as fast as it had been earlier. So when you can fill totally the ditch in, that's the preferred method in most situations. Next slide. So here's a photo of the fill operation at the time. This was a pretty big ditch. And for reference, the orange circle is that same wellhead we saw in the previous picture. This area does not flow anymore. It's full of dirt. So next slide. So now let's pivot and talk about floodplain reconnection. The image here shows the behavior of a river in similar flow situations. So the flow in the top and bottom picture is the same amount. Floodplains work best when the channel goes over bank about every spring, as depicted in the top image. You can see the water spreading out, losing its energy, dropping its sediments, doing all the good things that floodplains do that we talked about in part 1. Excess energy can cause a channel to insize and become disconnected from its floodplain, as depicted in the lower image. So the channel is trying to react to the excess energy and it's changing its form. In this situation, it's digging itself deeper, and that allows a larger flood necessity before it actually spreads out onto the floodplain. Next slide. So here's a current picture of that wetland we showed earlier that had been affected by the channelization. Remember that going from right to the left? You'll see now that on the right-hand side, you don't see the channel anymore. And in this case, natural vegetation was allowed to grow. That effectively filled in the ditch and reconnected the floodplain hydrology here. You can see on the left-hand side, it hasn't quite filled that portion of the ditch in yet, but good things are happening here. Now, this method works well in very low gradient situations. However, in most cases, other interventions are also needed. Oftentimes, we've channelized things enough where vegetation does not have the ability to refill the channel like this situation. Next slide. Now, drainage ditches have been created to make land dry enough to farm, right? That's their purpose. But in doing so, they also oftentimes run through areas that are unsuitable for farming. In these places, ditches oftentimes can be manipulated to allow snowmelt and spring runoff to spread out of the ditch, rehydrating wetlands and channels in these unfarmable areas. These concepts, used mostly in other regions of the nation, are beginning to gain attention in Wisconsin by agricultural managers, especially those in the Central Sands area where water infiltration is so important. The example shown here is on a property I managed in the intensively irrigated Yakima Valley of Eastern Washington, by the way. This ditch adequately drains cropland upstream of this photo, but is allowed to spread out in this area where there's no cropping taking place. Practices like this benefit farmers by increasing infiltration, recharging groundwater, and managing flood flows. And there's a lot of different ways you can do this. And in the Central Sands, with some of our large drains, you talk to the potato farmers in that region, and they'll tell you they have a tear in their eye every spring when they watch all their water that should be infiltrating into the ground flowing through the ditch into the Wisconsin River and all the way down to New Orleans. That's water they would like to use to put back into the ground. Wetlands can help do that. Okay, next slide. Grade control structures are very effective at erasing channel incision and reconnecting floodplains. Now in Wisconsin, they've not received as much use here as they have in other regions, but that's beginning to change. In this photo here, we see two grade control structures. And this also is on a property I managed back in the Yakima Valley in Eastern Washington state. These structures lift the creek at this site 4 feet. Each structure provides a 2-foot lift. It's important to use, when you're doing this type of work, it's important to use rock large enough to handle the amount of flow that the river may experience, and to extend these structures well into the bank so the creek doesn't wash around it. This here is Toppenish Creek. The flows in Toppenish Creek that we were reconnecting to the floodplain can go from a low of 24 cubic feet per second all the way to 24,000 cubic feet per second. So the rock we used in these grade controls were literally 5-foot columnar basalt. Those are some big boys. So because flash flooding is such a problem in places like this, especially in mountain-fed watersheds like those in the Yakima Valley, downstream farms benefit immensely from this type of work. Reconnecting the floodplains reduces the flooding that occurs in downstream farmed and cropped areas and pastures. Next slide. So there are a few examples of successful grade control projects in Wisconsin. This one is in Black Earth Creek near Mazomanie, and it combines grade control structures and floodplain sediment removal to effectively reconnect the floodplain. Remember, we talked a lot about how our floodplains have been filled in with sediment, sometimes 4, 5, 6 feet of sediment from upstream erosion. In this area, they reconnected it with the grade control and removing some of that sediment. Next slide. And here's an example of an unsuccessful grade control structure. This is Pheasant Branch Creek in Middleton. This structure failed because the rock was not big enough and it was not keyed into the bank. Next slide. So spillways can be very useful in Wisconsin. They're not used as much, but you can oftentimes open up a levee with combination of grade control structures and get the water reconnecting into the floodplain area. Next slide. Beavers do all this stuff for free, as you know, but beavers oftentimes are difficult to apply in agricultural areas. You have to have swift and efficient ways of controlling the problem beavers. Next. Managed grazing is taking off around here and really helping restore these areas, the channels and floodplains. This photo shows a floodplain near Barneveld improved by managed grazing. Waist-high sedge is now dominating an area that previously had little vegetation. Next slide. So let's go back to Little Plover River. This is an area downstream of the ditch that we filled. This is the main river channel itself. In here, the flashy flood events that used to occur actually caused the channel to widen and shallow itself. That also disconnected it from its floodplain, similar to incision. So what we did here, remember we talked about how this area had really filled in with thick forests? The solutions here were thinning the forest out, opening that area up, allowing the bank holding grasses and sedges to reestablish, taking the cuttings from those, the thinning operations, and then helping narrow the banks back together to get the form of the channel narrowed again so it would interact with its floodplain more frequently. Next slide. And this is what it looks like. Open floodplain forest, grasses and sedges returning, and the channel becoming deeper and narrower. The floodwaters are spreading out every spring. So now we have poll number 4. And I know we're short on time, so let's dive in.
Okay, so the question here is, which of the following types of wetland restoration practices would you like to learn more about? Again, we know we just scratched the surface today. Some of these are on farm, some of these are upstream of your farm. But we're going to use this information in collaboration with UW Extension to think about what kind of programming we might develop for the future. Okay, we'll just go about 10, 15 more seconds here. Okay, thank you, Erica. Okay, Tracy.
All right, thank you. Next slide. All right. So how do we apply this in community-based watershed initiatives? How do we get these things started to really get some stuff going in our watersheds? Next slide. We'll once again use the Little Plover River as an example. In Little Plover River, we have agriculture, industry, and urbanization happening. Next slide. So the first step is to build a diverse set of partners. The partners in Little Plover River represent all interests in the watershed, especially those who have influence and control over what happens on the ground. So here the village was important, Portage County, and the agricultural community. They all took leadership roles. Nothing could happen in this watershed if these people were not in leadership positions. Next slide. Secondly, developing a common vision and goals is paramount. This guides the work and helps people understand where the end point is and where they're going and how they fit in. Next slide. And of course, you have to do this kind of work based on good science. We were lucky to have a really robust groundwater surface water model to work off of here. So basing this stuff on good science and going through the questions that we talked about today is really important. Next slide. And get people involved early. Get work started on the ground as the planning efforts are occurring. Do the no-brainer stuff. Get people involved, bring people out on the ground, and get ownership in the work that's being done so people can see what's happening as the planning. If you plan forever and don't do anything on the ground, people will lose interest. Next slide. And get folks out on the ground, as we said. Here's a photo of students from UWSP, a forestry class, out thinning the floodplain forest. Next slide. Finally, never underestimate the power of communities. When agricultural communities identify a commonly held problem, The power of people that come together as neighbors and work shoulder to shoulder to solve that problem, from my opinion, is one of the strongest forces on earth. Don't ever forget this. Next. Finally, what's your role in on-farm and community-based water management? Crop consultants and agricultural support folks are uniquely qualified to help implement the actions outlined today on farm and watershed scales. You see the big picture. You often work across the landscape, not just on one farm, and you're well trusted by the agricultural community. So help us help you. Please complete the poll at the end of this webinar. It will help us guide future work. Next. And thank you so much for your interest. Sorry it went a little bit long. Our contact information is here. Please send us an email. Right now we are not in the office, and we're happy to answer your questions and do whatever we can to help you.
Thank you, Tracy and Erin. We can take time for questions. If you do have any questions, please type them out in the chat box, and Tracy and Erin can answer those now. And a reminder, if you are a crop consultant listening in and have not typed in your name and information to me in the chat box yet, please do so. If you are a crop consultant and missed some of the previous webinars, they are recorded and available on our website, and feel free to watch those and self-certify yourself as well. Tracy, I have a question for you. With some of those spillway structures and the half pipe structure you talked about, what is kind of the economic scope of installing one of those structures, and is there any cost share funding available if you're interested in putting one in on a farm?
Yeah, there's actually a lot of cost share options available. U.S. Fish and Wildlife Service has the Partners for Restoration program. That's a wildlife habitat focused, but oftentimes if you have a wetland situation like this, it may be appropriate for that funding. NRCS, of course, is one of the major sources of funding, and they'll fund all kinds of projects, especially through the EQIP funding. So seek out your local Pheasants Forever biologist and show them the situation that you're dealing with. It depends on the situation, but spillways and water control structures can be done relatively inexpensively. When you think of the years of benefits you get out of them, it's oftentimes well worth it. And I will emphasize that spillways are so important, because oftentimes what we do is we'll put something up to hold back water, and if those structures get overwhelmed, they can blow out. So a spillway, a hardened spillway, directing overflows safely through an area is money well spent.
Great, thanks. A reminder, if you have a question, to type it in the chat. And as Tracy mentioned, we will be sending out a survey at the conclusion of this webinar later this afternoon. So please take a minute to respond to that when you receive it in your email inbox. Okay, I'm not seeing any questions, so I would like to thank Tracy and Erin for their time and the information they've shared. It's been a very valuable 2 webinars, and I will be posting the recording on our website at the conclusion of this, and thank you again.
Thank you all.